This question is from Atomic Structure chapter. Question says the kinetic energy of an electron in second Bohr orbit. So we have to find in second Bohr orbit of a hydrogen atom is. So that is second Bohr orbit, that is n is equals to 2. So second Bohr orbit. So we have to find what is the kinetic energy. So second Bohr orbit, this means n is equals to 2. Now kinetic energy is given by half mb square formula. So kinetic energy is half m b square, and we can apply mbr is equals to nh by 2 pi, that is angular momentum is conserved. So mbr is equals to nh by 2 pi. From here we can find b, but second Bohr orbit, what is the radius? First Bohr orbit radius is given as a naught, and if you remember, we know radius is given by a naught n square by z. So radius of any Bohr orbit is given by this formula. R is equals to a naught, where a naught is the radius of first Bohr orbit, into n square divided by z. So if I plug this value for r, I will have mbr. R is nothing but a naught n square by z. This is equals to nh by 2 pi. So if I cancel, so I will have mba naught, and for hydrogen we can plug z is equals to 1. So let us say z is equals to 1. Now 1 and 1 and cancels out, so I will have only 1 in this side is equals to h by 2 pi. We can also plug the value of n is equals to 2. So mb a naught into 2 is equals to h by 2 pi. So from here we can calculate value of v. So value of v is h by 4 pi a naught m. Now we can plug in kinetic energy expression. Kinetic energy is half mv square, and v is nothing but h by 4 pi a naught m. So we will have half m, this is h square by 16 pi square a square m naught m square. 1 m goes, so I will have h square divided by 32 pi square a naught square, and 1 m cancels out here, so I will have only 1 m. So I will have to see which option is correct. H square by 32, so we have to have we have only 132, h square by 32 pi square. So answer in this case is C.